welcome to my shop. I built this place for a few reasons. First of all, I always admired Dave Richards' shop on YouTube, the whole steam-powered machine shop. That's quite a place. Second of all, I'm a big fan of self-sufficiency. So the basis of this shop, it's built supposed to resemble a 1920s, 1930s rural machine shop / repair shop that every small town in this area, being rural Ontario, Canada, as well as most of the United States, every small town would have had something similar to this at one time. It started off as a blacksmith shop. I put it together to repair a sawmill I was building at the time. Still have to build another project. So I have a forge in the middle with a couple anvils, a hand crank blower on it. It's powered. I burn soft coal, same as a traditional blacksmith. And from that it kind of expanded to being a machine shop where I could run a lathe and a drill and all that type of thing. So you can see here, this is my drill press, absolute creme de la creme. It's beautiful 1883 patented Barnes 20-inch drill with the power feed system. That I was really looking for that. It has a tight loose pulley, and I'll explain. This is a central drive shop known as a Lineshaft driven shop. Here's the shop cat. So the idea is you'd have a single power source. Before electricity came around, in this area specifically this road, 1952 electricity came, so before that it was all other forms. You'd have initially a water wheel, way back in the day, a water wheel or a windmill to do whatever the task would be, to grind grain or saw wood or whatever. Then came steam. Steam was allowed you to be away from a waterway, for example. You still needed to provide water for the boiler, but anyway, that was the next step. And then came internal combustion engines, gas, kerosene, diesel, all that. And then came electric. So central power meant you had one power source to run everything in the shop. You had a shaft somewhere centrally located, and every machine had a counter shaft, which was the small piece above it or part of it that would allow you to turn the machine on and off. So every machine was not always running. Most of the time that was in the form of a big lever overhead, something like this, and you'd manually shift a pulley from a drive wheel to an idler wheel. So you can see here the shaft. This is the hanger. There's bearings, which are made of babbitt. It's a lead alloy, so it just wears. You keep oil on it, and the steel shaft spins on it. And as long as there's oil, it's hydrostatic lubricated. As long as there's oil, it'll pretty well spin forever. And if it is to wear out in the long run, you can melt the babbitt and recast it back into the bearing. No need to purchase roller bearings or anything external. You do it in shop. The pulleys, they vary in size because the main shaft always spins at the same speed. So in my case, I have an electric motor on the roof to turn it, mainly for display. I have a gas engine at the side to run it when it needs load, and I'm working on a steam engine. So the main shaft, line shafts would normally run, this is a small one by the way, this is a bit over maybe 1.25 inches. A normal industrial shaft for a factory might be around 2 inches. So this would always be spinning at the same rate. You'd have your motor or engine governed so that the shaft would run around 350 RPM, let's say. So depending on the size of your pulley and the ratio of a large to a small or small to a large pulley, you set the different speeds of each machine. In some cases, I'll show you, for example, in this milling machine, you have a stepped pulley that has multiple diameters, which allows you to change the speed of the individual machine going by a change in ratios. Very, very manual, very basic, everything you can do here. I like the flat belts as well. Line shafts, some people use them with V-belts, a bit more modern, but I like the flat belt because you can cut it, relace it, or put the clips in, all here in the shop, and I'll show you that down the line as well. It's just a crimping machine, basically. So that provides the power. Every machine has a belt that runs to it, and you can turn it on and off. Other than that, every machine in here is familiar. The concepts are the same as modern mills. This is just a horizontal milling machine. You can put a vertical head on it. It's all manual though. The drill as well, it's the same as a drill press, the same, but everything's exposed. This drill also has a back gear reduction, a planetary gear set, so you can gear it down to cut really, really low and big holes. This is a Morse taper 3, which is the taper the size of the drill that it can accept. Here's an example. That's about a 1-inch drill bit that goes straight in there. I have a chuck for smaller drill bits on there right now. But so the drill, the mill, I have this lathe. This is a beautiful lathe, 1915. I fully restored that one, and the video is going to be up on it soon. You can thread, you can do everything. It's it's a small size for most lathes of this era, but you can pretty well do whatever you need, and it's perfect for me. It's a 5-foot bed, 10 or 11-inch size swing. And there's a slaughter machine, which is like a vertical shaper. That's going to come in the future, and a pedestal grinder going to come right here, so you can stay tuned for those updates. I also have a manual drill press with a hand crank. That one works like a top. That's a ratchet for a power down feed. This here is the first machine that I restored. It's a AB Jardine post drill. It has 2 speeds, which makes it really neat and not quite as common as most. This is just a standard chuck. It has a straight 1/2-inch chuck with 2 set screws, so I put a modern Harbor Freight or Princess Auto chuck in there. And this I use all the time. It runs like a top. There's a little pawl on top that if you flick, it ratchets this wheel, which turns the spindle downwards, and it automatically feeds into the piece of work. So I have it set right now where I can comfortably drill steel, and it's no problem really. You can wind it up, and flywheel carries the momentum. The gears are in great shape. Just oil the heck out of it and go. There's a bandsaw coming along, so basic wooden things. And the long-term goal is to power this with the steam engine, so I can use scrap or use wood to run the line shaft, to run the machine shop, and maybe even put a dynamo to generate lights. So complete self-sufficiency as far as I'm concerned, aside from lubricating oil. But that's a whole other rabbit hole to go down. So we'll move along, and I'll show you some things specifically and how they operate. This is a little 1.5 horsepower Fairbanks Morse engine that I can use to run the shop if I hook a belt to the other side and run it to the line shaft. It's made in about 1922, has a flick magazine, a flick magneto on it, and it's a throttle governed engine. It's not a hit and miss, so it fires every time. Let's see if it'll start. Turn on the drip oiler, give a few cranks with my hand over the intake for choke. This is the carriage on the lathe. It's a 1915 Myers made in Pennsylvania. You can see the manual advance. This little thing here is a clutch. When you engage it, it basically is a power feed. There's a key inside the lead screw. So the lead screw is good for threading, and it's also, the whole thing is keyed, which was when this clutch operates here. When you want to thread, you have this half nut. If you can see it engage or not in the back. There it goes for threading, and the dial I have, it has to bolt onto here for indicating. This is kind of neat. This is a power cross feed. There's a worm wheel and a gear in there. Just have to change it a little bit, move it a bit, and it locks into place like that. And then when you turn the lead screw, it does power cross feed, which was quite neat. I had to rebuild that gear anyway. Have a look at my video about that one soon. This part of the shop is where I do the forging. I have the coal forge. It has a hand crank blower on the back. Just a Champion number 200. I think this came out of a railway shop or a semi-portable railway setup. It doesn't have a shaker like a coal breaker on the bottom, clinker breaker. It just has a cast grill. Anyway, it's perfect for what I need. The problem is it had a flat bottom, so I had to stack clay from the creek bed on top. You could use fire bricks or stuff like that to form a bit of a pot instead of having a conventional cast pot in the bottom. So here's the rack of different tongs in the front. Big hood with a big chimney that goes straight out the roof. It's about a 13-inch diameter chimney, so I get good draw. This is a hay button anvil, about 140-50 pounds, and there's a Peter Wright anvil over there, about 165. Anyway, this is what got me started, and I make hooks and hinges and brackets and all that type of thing, as well as repair I've repaired leg vices, big ones and stuff like that. But I'll put something in and give you an example. If you notice, I can't really do too much of perspective because this is a reasonably small shop. It's maybe 14 by 20 feet, and the line shaft is 18 or 19 feet, and it goes right out the wall. So anyway, I'll show you what's going on here. So the fire is going pretty well here. I just have a piece of 3/8 inch round in there, and I'm going to make it into a spike real quick. So I put this in. It's only been about a minute, and I put that in, and it gets hot pretty quickly. So there's a pretty quick square spike, nothing too fancy. If you wanted, you could round this out and then kind of draw it and make a curly Q finial and then make it into a hook or something. It's sometimes a bit difficult to work with these old anvils because they're majorly used. This one came out of a local shop, and the where you hammer the most has become bowed, so sometimes the work goes a bit wonky and then you have to correct. But that's pretty well as simple as it is. All this stuff is, for the most part, as soon as you work with it, you kind of get the feel for it. And that's the goal with this whole place, is just to tinker around, figure out how they used to do things, figure out how to make everything as it once was made, and fix things, most importantly, as opposed to throw them out in a disposable manner. And yeah, hope you enjoyed that little tour of my shop. I plan on making more videos like this and working in here, doing different things, hooking up the Rockford mill and the Myers lathe, and figuring them out. But that's ultimately what this place is about. I don't have any experience in machining or blacksmithing or whatever. It's just tinkering and figuring it out along the way, and experimenting, fixing things. All these things, like back in the day, there weren't textbooks for all this type of stuff. So it's building intuition, if that's possible. That's my goal. So I hope you join me again for these videos, and let me know what you liked, what you want to see more of, blah, 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 all that type of stuff. Till next time, have a good one.